Question 1. So these are some of the things we have done before, but we will like to do it again. Okay, so whenever we have questions of this kind, limit x tends to 0, tan x minus sin x upon x cube, we would like to try and do questions here, try and apply methods which are either L'Hopital, as I have already discussed in the lectures, or we are going to do series expansion. So there are two types of methods, right? L'Hopital, and we have series expansions. Okay, so today's session is mostly about trying to understand these questions, trying to understand what may come in the exam, which you are going to give. So this is mostly about that. So most of the time I will be solving the questions only and making you understand. And if you have any doubt in any question, do raise your hand. So for this question, it is useful to use series expansions rather than L'Hopital. So more often than not, you will be given a choice to either select one of these two methods. Okay, so stating that in mind, we have to choose series expansions here, because L'Hopital may, if you want to choose L'Hopital, try to choose it on a problem where the denominator vanishes quickly. In this case, you see it's a 0 by 0 format, obviously, but if you apply L'Hopital here, the numerator is still going to be in 0 by 0, numerator is still going to be 0, and the denominator still is going to be in the 0 by 0 format. So essentially differentiating one will give you, one time will give you 3x squared, differentiating again will give you 6x. So the 0 from the denominator is not going to get cancelled anytime sooner, right? Therefore, we are going to apply series expansion. Now, how do we apply that? You have already studied in the lectures. Tan x can be written as x plus x cubed by 3 plus 2 by 15 x to the power 5, and so on. And sin x can be written as x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial minus so on. And this whole thing is divided by x cubed. So in this type of questions, you need to understand that once we get to this point, we would like to use series expansions in order to cancel things off, and we want to extract the coefficient of whatever is in the denominator. So denominator is x cube, right? We want to find out the coefficient of x cube from the numerator, and any other term which is greater than x cube, like x5, x7 and anything else, those are going to get cancelled and become a 0, because limit x tends to 0. So first of all, see that x and minus x gets cancelled. Secondly, do note that x cube को अगर मैं common ले लूँ, so it will become 1 by 3 minus 1 by 3 factorial, I think. And then all the other terms like x to the power 5 into something plus x to the power 7 into something and so on, these terms will not be useful, because you can separately write them like this and so on. This one will get cancelled and you will get a numerical answer, which is 1 by 3 minus 1 by 6. But for the rest of these questions, these terms, you will see that these are going to be 0 because of this. You will always have a power of x in the numerator only itself, and since x tends to 0, all of this is going to be 0. So in exam, you don't need to even write this or consider this. आपको बस जो highest power of denominator है उसी के हिसाब से expansion करना है. So this will give you 1 by 3 minus 1 by 6, which is nothing but, I think 1 by 6, 2 by 6 minus 1 by 6, yeah. That is going to be your answer. Okay. So this is very important. If there is any doubt in this problem, let me know. If there are no doubts, it's fine. Okay. So let us move to next question. First, we'll complete a few questions from limits. After that, we'll move to definite integration, and then we'll move to differential equation to end it off. Okay. Okay. Question 2. So yeah. So question 2, right? Question 2 may I have this kind of a limit. So this is one of the kinds that may come. Now this is another kind that may come in the exam, जहाँ पे you will have sequences. So n square minus 1 into n minus 1 plus 2 square minus 2. You might have seen this question, but the reason why we are repeating this kind of questions is this is necessary, as जो questions आएंगे those are going to be just like the PYQs. So which is why we should revise all of the PYQs as much as possible. N minus 1 whole square minus n minus 1 into 1. And this whole thing is divided by 1 cube plus 2 cube plus all the way up to n cube minus 1 square plus 2 square plus all the way up to n square. And that is going to be all. So this is the question. Okay. Now in this question, since we have sequences rather than continuous functions which we can use L'Hopital and other kind of stuffs, what we need to do is this. We need to understand that the only way of solving these questions is dividing by the highest power. So what is the approach? Approach क्या होगा इसमें? The approach is divide by the highest power of n. Highest power of n. Okay. Now अगर मुझे ये निकालना है कि हाईएस्ट पावर ऑफ n क्या है फ्रॉम न्यूमरेटर एंड फ्रॉम डिनोमिनेटर, फर्स्ट आई नीड टू नो द वैल्यू ऑफ द सम्स. सो आई डू नो दैट 1 square plus 2 square plus all the way up to n square, this is nothing but n into 2n plus 1 into n plus 1 by 6. This is a cubic term, right? If I talk about the cubic term sums, that is 1 cube plus 2 cube all the way up to n cube, this has a highest power of 4. So it's actually n square into n plus 1 whole square by 4. So it's a 4th degree. It's a 3rd degree term. It's a 4th degree term. Right. And if I just talk about 1 plus 2 plus all the way up to n, this is just a 2nd degree. It's a quadratic term, right? It's n into n plus 1 by 2. To find out what degree it is, you just simply need to see how many n's are getting multiplied here. That much is enough to understand. So in this case, in this problem, if I rather write it like this, this limit. So first let me write down the numerator, which is n. So n is this, right? 1 square minus 1 into n minus 1, 2 square minus 2 n minus 2 and stuff like that, and then like n minus 1 whole square minus n 1. So I can simply write it in summation notation in the following way: k equals to 1 to n. So I have 1 to n minus 1 actually, right? K equals to 1 to n minus 1. And we have k square minus k. So the terms are going to be like this, whole into n minus k. That much is clear. Okay. Now break it down. Break it down like this: k equals to 1 to n minus 1, k square n minus k cube minus kn plus k square. Okay. Now you can understand that this is going to be n times summation of k square minus summation of k cube minus n times summation of k plus summation of k square. Again, the highest power in numerator then would be n power 4, right? Because a summation of k produces a quadratic. That means a summation of k square produces a n cube term, and a summation of k cube, which we have just seen, produces a n to the power 4 term. So my limit is nothing but limit n tends to infinity. If I could write it like this, numerator is going to be n into summation of k square minus summation of k cube minus n times summation of k plus summation of k square, and denominator is summation of k cube minus summation of k square, right? So if you notice, if I am going to divide by the highest power of n, which means it is the same as dividing by the highest term, which is k cube, summation of k cube. If you divide up and down by summation of k cube, which is basically essentially saying that, okay, I am dividing by n to the power 4 to be precise, then the numerator is going to be n into summation of k square by summation of k cube. So I'm basically dividing up and down by summation of k cube. This is going to be 1. I'm only writing the numerator right now. This is going to be n into summation of k by summation of k cube, and this is going to be summation of k square by summation of k cube. In the denominator, it's going to be 1 minus summation of k square by summation of k cube. Now notice that any limit where n tends to infinity, any expression involving a 1 by n to the power something is going to be 0, right? Because limit n tends to infinity, 1 by n is 0, and any higher part of n is obviously 0 as well. So you notice that except this term has a n, and summation of k produces n square, n squared term. So n square into n, the highest power of n into summation k is n cube, while the highest power of summation of k cube is n to the power 4. This is going to produce a 1 by n because the denominator is greater. It is of a greater degree. Similarly here, it is going to produce a third degree term. This is going to produce a fourth degree term. So in limit n tends to infinity, both of these terms are going to be 0, 0. Similarly here, 0. So what you would be left with is this: limit n tends to infinity, n times summation of k square by summation of k cube minus 1 by 1. Okay. Therefore, I can simply now write this as following: limit n tends to infinity, n into, let me put the value of k square, n into n plus 1 into 2n plus 1 by 6, and summation of k cube, which is n square into n plus 1 whole square by 4 minus 1. This is the minus 1 which I have written here, and the divide by 1 just simply vanishes off. Okay. Therefore, this 6 by 4 can be written as 4 by 6, which is nothing but 2 by 3 into limit n tends to infinity. So n into n and n square cancels off. N plus 1 and n plus 1 cancels off to produce n plus 1. You simply have 2n plus 1 by n plus 1 minus 1. Okay. So this becomes 2 by 3 multiplied by. Now this can again be solved by dividing by n, which is the highest power, which means 2 plus 1 by n by 1 plus 1 by n. Again the 1 by n's go to 0. So you simply have 2 by 3 into 2, because 2 plus 0 by 1 plus 0, 2 by 1, which is 2, minus 1, which is 4 by 3 minus 1, and therefore the answer is 1 by 3. So yeah, this kind of questions again are not particularly very tough to do, but you have to be careful. Okay, just look at the solution for 2 minutes and let me know if you have any doubts. We'll go to the next problem after this. So this is what they're asking you to find: the value of 2f2 plus 3f3. Okay, so in order to find this value, first of all, whenever I see a limit of this form where I have like a 0 by 0 format and I have this kind of things, of course differentiating up and down using L'Hopital is going to be my first choice, because right now I cannot apply any series and there is no need to. We always apply L'Hopital when the denominator, which is in the 0 form, can be simplified easily. So here I see t is the variable, I see only a t in the denominator, and of course it's a 0 by 0 form, so I can definitely apply L'Hopital here. So solution: applying L'Hopital, we get limit t tends to x, t square. Okay, so let me just apply L'Hopital directly. So t square would be 2t, because we're differentiating, 2t f of x minus x square f dash of t whole divided by 1 is equals to 1. Okay, now simply apply the limits, which means just put the value. 2x f of x minus x square f dash of x is going to be 1. Now let me divide both sides by minus x square. This would give me f dash x minus 2 by x f of x is equals to minus 1 by x square, I think. Whenever I have this kind of a format, I need to find the integrating factor, right? Because this is in the form dy by dx plus py equals to q, and the integrating factor is e to the power integration p dx, right? So I need to find this integrating factor here. So I understand the p is minus 2 by x, which means the integrating factor is going to be e to the power minus integral of 2 by x dx. Therefore it is going to be integral of minus 2 ln x, which is x to the power minus 2. This is going to be my integrating factor. Once you get the integrating factor, you can simply find out the answer to this, because you can simply write y times x to the power minus 2 is equal to integral of minus 1 by x square into x to the power minus 2 dx. And this is what we want to write once immediately after we find integrating factors. So basically you are finding y. So once you find the integrating factor, you write y into the integrating factor is equal to integral of whatever you have on the right hand side multiplied by the integrating factor and the integral of it, the whole integral of it. This is your answer. So what you are left to do is simply find out what is the right hand side, which is easy to do because minus this is 1 by x to the power 4 dx, which is nothing but I think 1 by 3 x cube. 1 by 3 x cube plus c. Therefore, y is going to be, if you multiply x square on both sides, this is going to cancel and it will become 1 by 3x plus cx square. Now we remember that f of 1 is 1, which means nothing but y of 1 is 1. So put x equals to 1 here, put x equals to 1, and what do you get? You simply get that 1 is equals to 1 by 3 plus c, which would give me c is equals to 1 minus 1 by 3, which is 2 by 3. Correct. And once we get this, we can now simply write that the value of the function f is nothing but 2 by 3 x square plus 1 by 3x. Okay. Now, the actual value which we wanted to find was 2f2 plus 3f3. This is equals to 2 times. Now, what is f2? 2 by 3 into 4 plus 1 by 6. And 3f3 is going to be 3 whole into 2 by 3 into 3 square plus 1 by 9. Let us simplify this. This is 16 by 3 plus 1 by 3. And this is going to be 3 cube by 3, which is 3 square. So 3 square into 2 plus 1 by 3. Okay. So 1 by 3, 1 by 3, 16 by 3 is 18 by 3, which is 6 plus 9 into 2, which is 18. And the final answer becomes 24. This is going to be your final answer. Hopefully that was easy to understand. Now do review the steps. So I'll just zoom it out a little bit here. You can see the steps here and let me know if you have any doubt. I'll give you 2 minutes. Yeah, so first of all, before starting it, I would like to use series expansions here. Okay, I would like to use series expansions because whenever I see a question of this kind, I do understand that there are 3 unknowns a, b, c, and only one equation is given, which means some conditions are to be extracted. Yes, you did by series expansion, right? Yeah, exactly. Because some conditions you have to extract from the fact that this limit is finite. So some coefficients are going to be 0. So first of all, we can write this like this. E to the power ax minus cos of bx minus cx by 2 into e to the power minus cx. And this expression here, this can be written as 2x square because you can adjust it by using a 4x square and a 4x square and then writing it as half into 4x square. That can be done, and this is equals to 17. Now apply the series expansions. Limit x tends to 0. This is 1 plus ax plus a square x square by 2 factorial and so on, minus 1 minus b square x square by 2 and so on, and this is minus cx by 2 into 1 minus cx. We only need the terms up to x square since the denominator is x square. Anything above that will always obviously get cancelled and be 0. Now we need to collect terms. So first of all, 1 and 1 gets cancelled, we can clearly see. Next we have limit x tends to 0. Let us collect the coefficients of x first. So we have a, and now I think we have minus c by 2. And then let us collect the coefficients of x square, which is a square by 2. Then I think we have b square by 2, and again we have c square by 2. Let us write like this by 2x square is equals to 17. Since the limit is finite, we must have a equals to c by 2. This must be true. And therefore, the limit becomes, after cancelling of this and this, it simply becomes a square plus b square plus c square by 4 is equals to 17. Or in other words, a square plus b square plus c square is equals to 68. Now, using the fact that c is equals to 2a, we can simply write 5a square plus b square is equals to 68. A nice question, and it's the fact that it can only be solved using series expansion this easily is really surprising, because this is not something you learn in class 11th and 12th, and it's definitely not in NCRT, and JEE Main is supposed to be based on NCRT, and it's a JEE Main PYQ. So we can already see how the questions are usually out of syllabus. Okay, let's do one more. Okay, so we have question 5. Limit x tends to 0, alpha e to the power x plus beta e to the power minus x plus gamma sine x whole divided by x sine square x, and this is equals to 2 by 3. And they have given a bunch of options, but I don't think that's important. What's important is we need to just simply solve this. Again, in this kind of question, we would again like to do the same thing as we have done before. We would simply do alpha and then write as 1 plus x square by 2 plus x cube by 3 factorial and so on. For beta, we will do beta 1 minus x plus x square by 2 factorial minus x cube by 3 factorial and so on. And for gamma, we will do x minus x cube by 3 factorial. Okay. And in the denominator, we are simply going to write it as x cube, because sine square x can be written as x square. You can adjust this by using x square here and x square here, and sine square x by x square as x tends to 0 goes to 1. So this is 2 by 3. Okay, so therefore this would mean that limit x tends to 0. Now again, since the denominator is x cube, everything else should cancel. So I think alpha plus beta is the constant term. Then for x, I think we have alpha minus beta plus gamma. And then for x square, I think we have alpha by 2, then beta by 2, and then I don't think we have other terms. And for gamma, for x cube, we have alpha by 6 minus beta by 6 minus gamma by 6. You can do a by x here, x cube here, you can do a by x cube here, you can do a by x cube here, and you can do a by x cube here. This is equals to 2 by 3. Okay, so obviously alpha plus beta is 0. This also applies here. This is number 1. Alpha plus gamma is beta, number 2. And number 3 is alpha minus beta minus gamma by 6 is equals to 2 by 3. So this is equals to 6 into 2 by 3. This is number 3, because that is actually the value of the limit. Okay, so from first we get the value of beta as minus alpha. And if I put it here, I get alpha plus gamma is equals to minus alpha, or gamma is equals to minus 2 alpha. So gamma and beta both in terms of alpha are found. And now here if I put the values, alpha minus beta is basically plus alpha, and minus gamma is basically plus 2 alpha, which is equals to 4. So 4 alpha is equals to 4, and therefore alpha is equals to 1, beta is equals to minus 1, and gamma is equals to minus 2. So alpha, beta and gamma are respectively 1, minus 1 and minus 2, and therefore we have solved the question. Okay, so yeah, this question again, another series expansion question, can be solved using series expansion very easily, and then whatever the options are, you can simply put it in and check it. But that's beyond the point. We don't need to do that much work here. Okay, There is no doubt in this, I hope. Let us do one more question and then go to finally differential equations and definite integration and punched questions of that. So this was question 5. Question 6, we have limit n tends to infinity box of r plus box of 2r plus all the way up to box of nr whole divided by n square, and we have to find the value of this given that box of function is the greatest integer function. It is the GIF function. Okay, so in order to do this kind of questions, we would like to, whenever the GIF is involved in any limit, we always would like to use the squeeze theorem. So basically I want to establish, if this limit is L, basically I want to establish some bounds alpha and beta for L, and I would like to see if alpha and beta go to the same limit when n tends to infinity, so that L goes to the same limit as well according to squeeze theorem, right? So for that I need to understand first. So let me check with an example. So if I say R is 5.5 and the box of 5.5 is 5, which means the box of a number is usually less than the number. So I can write that box of R is less than or equals to R, and it is strictly less than R minus 1. This we can understand. And in a similar way, 2R minus 1 should be less than box of 2R, which is less than or equals to 2R. And if you continue this, you can get NR minus 1 less than box of NR less than or equals to NR. Okay. Now, with this in hand, we can find out that firstly, that let me just write it directly. So R minus 1 plus 2R minus 1 plus all the way up to NR minus 1 whole divided by n square. This should be less than or equals to box R plus all the way up to box of NR by n square is less than or equals to R plus 2R plus all the way up to NR by n square. Okay, so therefore the first function is nothing but R whole into 1 plus 2 all the way up to n by n square minus 1 by n, because there are n ones and those become basically minus n by n square is 1 by n, less than or equals to the same thing, box R all the way up to box of NR by n square less than or equals to R times n into n plus 1 by 2n square. So let me apply the value here as well. R into n plus 1 by 2n square minus 1 by n less than or equals to, let us apply limits as well so that I can write it as L. This is my required limit L, which is less than or equals to limit n tends to infinity R into n plus 1 by 2n square. We can easily see that the limits go to, this goes to 0 and this goes to 1. So therefore R by 2 less than or equals to L less than or equals to R by 2. By squeeze theorem, the required limit L is going to be R by 2.